Good evening, everyone. I hope every one of you have written your examination well. And just like in the previous years, in this year also, if you see the weightage of the subjects regarding to the ESE Prelims Paper-2. So there is no much deviation regarding to the weightage of the subjects. So if you see the weightage analysis, building materials as usual, they got the highest weightage. So out of the 150 questions, 16 questions came from the building materials, and next to that solid mechanics, so which comprises of 20 questions, and then structural analysis 4 questions, design of a steel structures 12 questions, and design of concrete and masonry structures 11 questions. So construction practice planning and management CPM 10 questions, fluid mechanics which includes of hydraulic machines and open channel flow, total of the 13 questions. And then engineering hydrology 8 questions, irrigation engineering 5 questions, environmental and geotechnical engineering as usual 13 and 13, and then surveying and geology 12 questions. So regarding to the transportation engineering, which includes the highways, railways, airports and harbors, so total of 13 questions. And the paper pattern went in such a way that the level of the difficulty is moderate, because certain subjects regarding to the structure related subjects, they have asked some typical level of questions, but apart from that you see the transportation engineering, you see the geotechnical, environmental or water resources related subjects, no much of the difficulty. So we can say the level is moderate, and whatever the pattern, whatever the questions that they have asked in the question paper, they are more related to the discussion that we had in our classroom practice questions and in the classroom videos, online recorded lectures also. Okay. So now let's see some of the questions regarding to the geotechnical engineering first. So which one of the following type of soils will usually shrink if drained or if subjected to the repetitive loading? So the point is here is, so if the load is applied repeatedly, or if you apply dynamic loads or impact loads, which of the soil will undergo shrinkage or breakdown? So out of all the soils, if you see the silt structure is a honeycomb structure. Honeycomb structure is so strong under a static loads or under application of one particular load. But if you keep on apply the same load repeatedly or under the action of impact or dynamic loads, the honeycomb structure will break down and it is going to be shrink. So the correct answer is option D, which is nothing but silts. Now come to the question number 46. So if you see this question will be discussing in geotechnical engineering and environmental engineering also. In geotechnical engineering, we deal with respect to the sedimentation analysis for the fine grained soils. Similarly, in environmental engineering for water supply engineering, so in case of the plain sedimentation, so both concepts are dealing with the Stokes law. Now if you see, they have given the terminologies as gamma S unit weight of the material, gamma T unit weight of the liquid, and according to the Stokes law, what is the formula for the terminal velocity? So basically Vs is equals to the terminal velocity g by 18 into g minus 1 into d square by nu. But from the given options, if you take out this equation, V is equals to 1 by 18 into, you can write down that gamma S divided with the gamma T. So take out the gamma T, which is nothing but gamma S by gamma T minus 1 into d square by mu. So gamma S by gamma T, which is nothing but unit weight of solids to unit weight of the fluid, that comes as a specific gravity. So this is going to be G, and you can write the unit weight of the fluid as rho into G, and you send the rho to the denominator. So eventually you know nu is equals to mu by rho. From the given options, the first option is related to the equation of g by 18 into g minus 1 into d square by nu. So option A is correct. Next, consider the following statements regarding sedimentation analysis. So similar to this is also sedimentation analysis, and now sedimentation analysis of soil particles based on the Stokes law. So for the sedimentation analysis, what are some of the assumptions or statements that we took based on the Stokes law? If we see one by one, the finer soil particles are never perfectly spherical. Yes, in soil the finer particles, they are never perfectly spherical, that isn't practical. But for the analysis, in sedimentation analysis, we assume that the finer particles are spherical. So they are not asking practically, they are asking what is the statement regarding to the Stokes law. So as per Stokes law, Stokes assumed that all the fine grained particles are perfectly sphere. So the first one is not regarding to the Stokes law. And second one, all soil grains may have the same specific gravity, just like that. See, in the case of the fine grained soils, different particles will be having different specific gravity. But as we assumed all particles are spherical in shape, we also assumed every particle will be having an average specific gravity which may be same. So as per Stokes, every particle has the same specific gravity, which means all the soil grains may have the same specific gravity. So statement 2 is correct. And now if you see, based upon the first statement itself, we can get down the answer, because if you go by the elimination procedure, one is incorrect. Option A eliminated, B eliminated, and D is also eliminated. So the correct answer is option C. Okay. And the third one, particle constituting the fine soil fraction may carry the surface electric charges. Yes, that's one of the assumption. Next, come to this question number 48. What is meant by thixotropy? What is meant by thixotropy? When you disturb a cohesive soil with respect to time, it attains the loss strength. With respect to time, it attains whatever the strength it lost, it tries to regain it. And during this process, there is no change in water content, there is no change in volume also. So such a property we call it as a thixotropy. So if you see, the options are option D. Phenomena of the strength loss, strength gain, strength loss, strength gain with no change in volume or water content, option D. Next, come to this question. So this question, now consider the following statements regarding to the energy heads. The velocity head in soil is negligible. You know that as per Bernoulli, the total head is nothing but pressure head plus velocity head plus datum head. But in the case of the soils, as water passes or flows through the void spaces or pores, usually the velocity of the flow is very, very less. When the velocity is less, then square of the velocity divided by 2 times of gravity, that is going to be much lesser. So simply we neglect the velocity head. Yes, statement number 1 is correct. Now come to the statement number 2. Direction of the flow is determined by the difference in the total head. Obviously, always flow takes place or happens from higher energy level to lower energy level. So without difference in the energy, there is no flow. So the direction of the flow is going to be determined based on the difference in the total head. Yes, this is also true. And come to the third statement, negative pore pressure cannot exist. No, negative pore water pressure will exist in the case of the dense sands and over consolidated clays. Why? In case of the dense sands, during shearing, after a certain point of time, the interlocking between the particles will break. When the interlocking between the particles will break, the volume will increases. That's known as a dilation. So during the dilation, when the particles move away, the pore pressure present in the void spaces will relax, which means it decreases. So that you will get the negative pore water pressure in case of the denser sands. And that too, when you apply the shearing, so it loses, there is a breakdown of the interlocking between the particles. So the statement number 3 is incorrect. The correct answers are 1 and 2, which comes in the option A. Now, what is the value of the coefficient of permeability for coarse gravel? Generally, for the gravel, the coefficient of permeability is greater than or equals to 10 to the power of 0 centimeter per second. So which means 1 centimeter per second. But they have asked in terms of the mm, so now convert that in terms of mm, that becomes 10 mm per second. So usually for gravel, permeability is greater than or equals to 10 mm per second. That comes as option B. Next, a reinforced concrete foundation of dimensions L by B. So L is 36 meters and B is 18 meters. Exerts a uniform pressure of, so the pressure is given as 180 kilopascals and Young's modulus is 45 million Newton per meter square, which means 45 into 10 to the power of 3 kilonewton per meter square. What is the value of immediate settlement under the foundation? So if you look over the immediate settlement, the equation goes as Q by E into B into 1 minus mu square into I, where Q is the pressure applied at the footing, where E and mu are the elastic constants. But in the given question, as they have not given the mu, which is nothing but Poisson's ratio, you know the maximum value of the Poisson's ratio are for a perfectly elastic clay. So the value of the Poisson's ratio we can assume it as a 0.5, and as I value is not given, you can assume it as 1. So now if you do substitute here, SI is equals to Q value comes as 180 by 45 into 10 to the power of 3 into B value as 18 into 1 minus 0.5 square into 1. So if you do solve all these things, then you are going to get this one in terms of 54 mm. So the correct answer is option D. Option D. Okay. So this is the one that you need to apply as it is a ESE prelims question. So now if they don't give you the proper data, what we have to do is we have to go with the proper values by assuming. Okay. Now which one of the following terms defined as a maximum pressure which a foundation can withstand without the occurrence of a shear failure? Without occurrence of the shear failure, the maximum pressure that foundation will take care or the maximum pressure that soil can bear is nothing but ultimate bearing capacity. So which is option C. The correct answer is option C. Next. So this question 53 is just similar to the question number 51. The equation, whatever the equation I have given, that is the immediate settlement. So related to that only, they mentioned if SI is a immediate settlement at a corner of rectangle and they have given the Q, Young's modulus, Poisson's ratio, then what is the immediate settlement of a foundation? Just now I have given you the equation Q by E into B into 1 minus mu square into I. So from the given options the correct answer is option D. Option D is the correct answer. Next, consider the following statements regarding bearing capacity values specified in the building codes. So as per the building codes, what are the correct statements? The codes tactically assume that allowable bearing capacity is dependent only on the soil type. Yes. So whatever the bearing capacity deals or depends on the soil type only. So now one is correct, and then the codes assume that bearing capacity is dependent on the size, shape and depth of the foundation. You see the first one and second one. First point says that it depends upon soil, but second point says that it depends upon the foundation details. If first is correct, then second is directly. You can eliminate that, and if you see the options, the only option that eliminates the option number means the statement 2 is option B. So the correct answer is option B. Without seeing the third statement, you can opt for the option B. Okay. Now what is the grain specific gravity for the humus type of soil? The humus comes under organic soils. So for organic soils, the specific gravity of the solids is usually less than 2. Now from the given options, whichever the option is less than 2, so option number means option B. So that is 1.37. So the correct answer is option B. Okay. Next, when the specific gravity of the solids is known, so means G is known, then which one of the following types of methods is used to determine the water content? So in order to determine the water content, if the specific gravity is known, then directly you can go for the pycnometer method, because pycnometer method is the method where you can find both the specific gravity and water content. So option A. Next, which one of the following soils are transported by wind? So whatever the soils that got transported and deposited by means of the wind, we call it as a L1 deposits. So that comes as a option C. So these are the questions related to the geotechnical engineering. Now let's move on to the open channel flow. So from open channel flow we got 2 questions. Now if you see those questions, consider the following statements regarding uniform flow in channel. So we are asking about the uniform flow. First of all, what is a uniform flow? Uniform flow means a flow with a constant velocity. Whatever the flow with a constant velocity or flow with a constant depth. So dou y by dou s, dou v by dou s is equals to 0. So there is no change in depth, no change in velocity with respect to the length. Now if you see the options, the depth of the flow and wetted area are constant obviously. So the depth is same, and you know when velocities are same, as per continuity equation, when the velocities are same, then areas also must be same. So statement number 1 says that depth is same, areas are also same. So statement number 1 is correct. Next, the velocity of flow and discharge are varying along the channel. If the velocity and discharge changes, they are not uniform, they are non-uniform. So statement number 2 is incorrect. So now eliminate the statement number 2. If you see, eliminate option A and option B. But still the total energy line, water surface and the channel bottom all are parallel. In case of the uniform flow, if you see the channel bed, when the depth is same, the water surface is exactly parallel. When the velocities are same, the total energy line is also going to be parallel. So this water surface line we call it as HGL, and this is nothing but the bed. In case of the uniform flow, all the slopes are same, which means TEL, HGL, bed, all are parallel to each other. So statement number 3 is also correct. From the given options 1 and 3, option D. Next, see this question. So if Q is a discharge in the channel, in a channel, and A is a cross section area at the entrance. So at the entrance of a channel they have given the discharge and area. Now if dn is the depth of the channel entrance, suppose this is a channel and there is a depth of the flow and the depth of the flow is a dn. What is the equation for the depth of reservoir when the flow in the channel is a subcritical? So generally for the reservoir, the bed of the reservoir is usually horizontal. The bed of the reservoir is usually horizontal. So this is a reservoir, fine. And now for the channel, obviously we know for the channel bed there must be some longitudinal slope. And they have given a condition. What is the condition is when the flow in the channel is a subcritical. When the flow in the channel is a subcritical, which means on the channel the flow must be subcritical. Subcritical is going to be possible if the flow lies above CDL, means critical depth line. And you know that in case of the change in slope, see this is a horizontal and this is some other slope. Always a flow happens between NDL to NDL, right? So there must be some depth over here in the reservoir. And definitely in this channel when it meets, it has to meet the NDL and the flow must be subcritical. So it meets NDL and flow is subcritical, which means NDL should lie above the CDL. That happens if and only if the given slope is mild slope. In the case of the mild slope, Yn is greater than Yc. So somewhere over here there is a NDL and there is a CDL. So obviously on the channel if the flow has to be subcritical, the flow has to meet the NDL which lies above the CDL. So simply the flow comes and meets the NDL directly. And what is the data they mention? In the given data, at the entrance of the canal the depth is given as dn. And what is the depth of water in the reservoir? So which is a dr. Obviously when we open the flow into the channel, so the flow is coming with some velocity, that is nothing but approach velocity. And whatever the level difference between these two will be nothing but the approach velocity head. That approach velocity head is v square by 2g, right? So now what is the depth of the reservoir? The depth of the reservoir is whatever the approach velocity head Va square by 2g plus at the entrance of this canal the depth of the flow is dn. So now how to find out the approach velocity? Already they mentioned the discharge and area. So now you can write dn plus velocity is nothing but q square by 2g a square. So from the given options the correct answer is option D. So these are the two questions from open channel flow. And now let's move into the environmental engineering. So in the case of the environmental engineering, now again 13 questions came from the environmental engineering. So let's see these questions. The first question is based upon the IS code 1173/1992 which represents the per capita demand. Now if you see the type of commercial building and water, in case of the restaurants we go for the 70 LPCD per person, which means for P it must be 2. And for nursing homes and medical quarters, so we must have to supply 135 per capita, and for cinema halls we have to go for the 15 per capita, and for factories it is going to be like 45. So from the given options if you observe 2, 3, 4, 1, so the answer is, the correct answer is option D. Option D is the correct answer. Next, consider the following statements regarding quality difference of the groundwater and surface water. First one, they have given 3 statements. The turbidity of groundwater is high whereas surface water is little. So see, in case of the groundwater when the water flows through the soil will itself act as some filter. So obviously the turbidity would be very less. Compared to surface water, groundwater has a less turbidity, which means statement number 1 is incorrect. Eliminate that. If you eliminate, So option A and option D can be eliminated. And coming to the second one, total dissolved solids of groundwater is lower than the surface water. No. In the case of the groundwater, when the water passes through the soil particles, whatever the minerals in the soil also will mix with the water. So obviously the TDS is more in groundwater than the surface water. So statement number 2 is also incorrect because TDS is higher. Then the only correct answer is, so option number means statement number 3. So the correct answer is option C. Now if P is a population of a town or a city, Q is the total quantity of the water required during 1 year for a town city, what is the formula for the maximum daily per capita demand? The maximum daily demand is 1.8 times of the average daily demand. But given is the total quantity of water required during 1 year. So for the given, that is 1 year, but I want for day. So given is for 1 year, as I want for day, this is average daily demand, which comes as 1.8 into per capita demand I want. This is for the total, and for one person divided with the population, and this is for per day, but given is for the year. So divided with the Q by for one person population, and as it is for day divided by 365. So the correct answer is option A. Next, if Pn is a population at the end of the decade, Pn is a population at the end of the decade, P0 is the population which is a present population, and the average population, that is nothing but x bar, which is a P average is given, and Pi, that's the average incremental increase. Actually the average incremental increase is y bar, which is given as like a Pi. So what is the mathematical representation of the incremental increase method? Actually there is no correct answer in this given expression, because for the incremental increase method, you know that population at any nth decade is equals to present latest known population plus n into x bar plus n into n plus 1 by 2 into y bar. So if you see the correlation over here, then Pn is equals to P0 plus P average into x bar plus n into n plus 1 by 2 into Pi. There is no equation that literally represents this value. You can get it done if you keep that n as a 1 or 2. You can get it done. Suppose if I keep n as 1, then if you observe over here, so yeah, if I keep n as 1, this one, yes, so n into P average. If I keep n as 1, so now you just keep it over here, and n plus 1, 1 plus 1 is a 2, 2 by 2 will get cancelled. So 2 by 2 will get cancelled, then n into P average and plus n into Pi. So approximately this Pn is approximately P0 plus P average plus Pi into n. Approximately you will get down the option which is related to the option C. But there is no correct answer. So we can adjust this answer based upon by substituting n value as a 1 decade. Okay. So from the given options, the correct answer is option C. Next, the impurities in water which are extremely small size and cannot be removed by settling and filtration. Whatever the impurities that cannot be removed by filtration or suspension, so those are nothing but the dissolved impurities, option C. Next, what is the function of the flocculator in the typical water treatment scheme? What is the purpose of the flocculator? The flocculator is where whatever the colloidal particles are there, after destabilization, it allows those particles to come closer, agglomerate and form as a flocculant particles, right? So from the given options, to provide for gentle mixing of the destabilized colloids, so which means after the destabilization, to promote agglomeration of colloids. So the correct answer is option C. Next, what is the function of the rapid mixing in the typical water treatment for the groundwater? So now the question is about the groundwater. In case of the groundwater, we do the rapid mixing before the sedimentation. Why? For the removal of the hardness, because in the case of the removal of hardness, we go for the lime soda process. When you add lime soda to remove the hardness of the magnesium and calcium, in order to occur the precipitates, we mix that entire chemicals rapidly. Okay. So the correct answer is to disperse the lime and soda ash to form the chemical precipitates. The correct answer is option D. Now, if Q is a water requirement in liter per minute and P is a population in 1000, what is the Buston's formula? So we know that there are some empirical formulas regarding to the fire demand. There are nothing but the Freeman's formula, Buston's formula and Kuchling's formula. So apart from that, now from the given question, the Buston's formula goes as option A, 5663 into root P. Next, What is meant by soffit? So soffit is nothing but, in the case of the sewer, if you take the sewer, so it will be having outer diameter and inner diameter, and whatever the topmost point inside of the sewer, this point we call it as a soffit. Okay, so the highest point of the interior of a sewer pipe, so whatever this is a sewer pipe, interior inside the highest point of any cross section, we take it as a soffit. Now what is the logical extension of the pit privy? So that's nothing but the composting toilet, which is option B. Next, consider the following statements regarding a good building or house drainage system. For the house drainage system, what are the correct statements from the given? So the pipes should be of non-absorbent materials, obviously. So it should resist the alkali, it should resist the basic nature and hard materials and all. So it should not take any other things like, so it should be of a non-absorbent material, yes, that's true. The system should have traps at all necessary points, yes, that's also true. The branch drains should be as long as possible, no. The branch drains has to be as small as possible for provide proper ventilation for the flow. So out of all these things, the statement number 3 is incorrect. So if you see, option A is correct. Next, what is the drawback of aerobically digested sludges? Actually, we can do the sludge digestion aerobically and anaerobically, because there are two types of sludges. So the sludge that comes from the primary clarifier, the sludge that comes from the secondary clarifier. In the case of the secondary clarifier, in the biomass, the organic matter is very less, where you can go for the aerobic decomposition. But the problem with the aerobic decomposition is obviously again it relieves some more precipitates. So when you treat the sludge again aerobically, the end product will be again whom? A sludge. And when there is a sludge, it is very difficult to remove that sludge out of the system, which means we will get a problem regarding to the dewatering. So from the given options, it's not about order or enhanced reputable, the problem is difficulty in the dewatering. Next, what needs to be maintained to avoid the order problem in ternary effluent? So in the case of the ternary effluent, we have to provide the pH value, always we need to maintain more than 9.5. Why? If you go with a pH value less than 9.5, hydrogen sulfide gases will be releases. So for not entrance of these hydrogen sulfide gases, we have to maintain always pH greater than 9.5. So the correct answer is option C. So these are the questions related to the geotechnical engineering, open channel flow and environmental engineering. So the next subject will be dealt by the other faculties.
Right. So, good evening everyone. So, regarding building materials, okay, we have seen in the question paper that we have 16 questions. So, this is as per the usual pattern. So, every year from building materials there are around 10 to 12% questions. So, this year, okay, total we have 16 number of questions from building materials. And regarding the level of difficulty of these questions, okay, I can say that okay, most of the questions are relatively easy. Okay, some of the questions okay were just they were stretching the boundaries of the syllabus, but they were relatively easier. Okay, and most of the questions okay they could be solved by elimination method. Okay, though the question felt that it looks a little difficult, but just by elimination of options okay questions can be attempted very easily. Okay, so we will discuss these 16 number of questions from building materials. Okay, starting with the first question, question number 1. Okay, so the question deals with permitted yeah. So the question deals with permitted amounts of acid or alkalis, permitted amounts of acids or alkalis in water used for construction work. Okay. Now regarding this, IS 456 says that you need water with pH range. So for construction work, the pH value of water should be in the range of 6 to 8.5. That is, it should not be too acidic. Less than 6, it is too acidic. More than 8.5, it is very basic. Okay. Now IS 456 says that when you take a sample of 100 ml, okay, that 100 ml sample, if it is acidic, okay, it should be neutralized with 2 ml of 0.1 normal sodium hydroxide, which is a base. Okay, that should be used for neutralization. Okay, or if it is acidic, sorry, if it is basic, then 10 ml of 0.1 normal hydrochloric acid should be used for normalization. So if the sample is basic, okay, 100 ml of the water sample, okay, it should be neutralized with not more than 10 milliliters of 0.1 normal hydrochloric acid. So option A is the correct option. Okay, so you will take 100 ml sample. Okay, if it is acidic, it should be neutralized by 2 ml of 0.1 normal sodium hydroxide. If it is basic, it should be neutralized with less than 10 milliliters of 0.1 normal hydrochloric acid. Okay, right. Okay, now next question. Okay, match list 1 and list 2. Okay, so on list 1 you have different type of bricks. Okay, sand lime brick, face bricks, paving bricks, and sewer bricks. Okay, list 2. Okay, in different type of list 2 indicates different type of construction works. Okay, now which kind of bricks are suitable for which kind of construction work? Okay, now coming to these bricks. Okay, here very easy option you can see, you can identify is that face bricks. Face bricks, they are used for elevation. Okay, so good appearance. They are generally used where distinct brick finish is required. So wherever good finish is required, you go for face bricks. Okay, so you got that. So just from this you can select the correct answer, that is Q is option 4. Okay, so other options, see, sand lime bricks, they are cheaper and used only for backup. See, sand and lime, okay, when they are mixed, the brick which you get, they have very low strength, okay, compared to your regular clay bricks. Now because of that, they are used as a backup, or for low quality works we use those kind of bricks. Paving bricks, basically they have to be tough and durable. See, on paving bricks there will be some kind of traffic movement. It can be people, it can be your vehicular traffic, light, medium, heavy traffic is also permissible in different type of pavers. Okay. So for paving bricks, tough and durable, because of traffic they are to be tough and durable. So last option, sewer bricks, sorry, my mistake. Sewer bricks, we are left with the option edges and curves to suit the shape. See, basically your sewer lines, okay, so sewer lines or drains, they are curved or circular in shape. For that, the bricks which you are used should also be in curved in shape. They should be curved in shape. Okay. So option C is the correct option. Right. Again, list 1, list 2, we have to match. Okay. Now this is about physical properties of cement. Okay. Now option P, loss of ignition. Okay. So when, in which situation the chemical reaction does not start or does not happen. See, where there is evaporation of moisture, if there is insufficient amount of moisture in your mortar or concrete, okay, if it is too low, then the cement particles will not hydrate, the hydration will not start. So P is 2. Insoluble residues. See, gypsum, okay, compounds like gypsums, okay, gypsum, they are insoluble. Okay, they don't react in any of the hydration reactions, they are insoluble. Hence, okay, insoluble residues are formed if there is inactive materials like gypsum. Okay. Lime and alumina content. Okay. Now, so lime, what does it do? See, if the cement contains excess amount of lime, then the cement will become unsound. The cement will become unsound. So it causes unsound behavior. Okay. Now, finally, sulfur content leads to expansion. See, in the cement, if there is significant sulfur content, it causes sulfate attack. Okay. So what is sulfate attack? See, there is significant expansion due to presence of sulfates. Okay. So that is sulfate attack, since S is option 1. Okay. So in that case, A, so option A is the right option. Next, which of the following is not a property of a admixture? Okay. So what are admixtures? Admixtures are materials which are mixed with concrete to improve or enhance certain desired characteristics. Okay. So we use admixtures for that. So what are the options? Improve workability, yes. Certain admixtures like plasticizers and superplasticizers, they are used to improve the workability. Increase the strength. See, if you are using admixture like calcium chloride, it will improve the early rate of strength gain. So there are admixtures which deal with improving the strength. Okay. Improve durability, yes. See, admixtures like even pozzolana admixtures or your high performance, for high performance concrete we use super plasticizers. Now super plasticizers reduce the formation of micro cracks throughout the concrete, which improves the durability. So we use admixtures to improve durability as well. Last option, increase permeability. Now this, okay, this is incorrect. See, admixtures are used to enhance the properties, not to damage the quality of concrete. So increasing permeability is not desirable, because of which, see, steel corrosion etc. will happen. So we don't use admixtures to improve or increase the permeability of concrete. Next, what is the temperature of the tensile strength of the stone in water? So, okay, there is a small issue with the wording of the question, okay, but the intention of the question is, if you want to determine the tensile strength of a stone, building stone, okay, now under submerged condition, okay, in which temperature range the stone should be maintained. So see, for all these kind of tests, okay, around room temperature, okay, the sample should be around in the room temperature, okay. So generally plus or 27 plus or minus 2 degrees centigrade. From the options we can deduce that it should be 20 to 30 degrees centigrade, okay. If you look up the code, it says 20 to 30 degrees, okay. Even if you don't know the exact value, okay, just by the small logic, samples for all kinds of physical tests of cement, steel, whatever it is, okay, the sample should be maintained at room temperature, that is 27 plus or minus 2 degrees centigrade. So this option is right. Now the decomposition of feldspar is represented by, okay, see, decomposition of feldspar, okay, based on this equation, it deals with, okay, the chemical weathering of this mineral, okay, the chemical weathering of this mineral, okay. Now under acidic conditions due to carbon dioxide, okay, there is weathering observed in feldspar mineral, okay. Now here, see, you can attempt this question, okay, based on one small point, okay, that is based on the chemical composition of feldspar, okay. If you remember the chemical formula of feldspar, okay, which is K2Al2O3, okay, K2Al2O3, 6H2O hydrated with 6 moles of water. It undergoes chemical weathering due to excess carbon dioxide in the presence of water, okay. This is the decomposition, okay. So K2Al2O3, okay, if you can remember that, okay, based on that you can attempt this question, okay. So feldspar chemical formula K2Al2O3, hence option B, okay. Next, match again list 1 and list 2, okay. So list 1 we have different type of stones from which we prepare different rocks from which we prepare different type of building materials, okay. List 2 different type of construction elements, okay. In list 1 we have trap or basalt, okay. See, trap or basalt, they come under your igneous rocks, and we know igneous rocks, aggregates obtained from igneous rocks are very strong, very durable, so we use them as aggregates for concrete. So directly trap or basalt, you can use it for road metal and concrete aggregates because they are strong and durable, okay. Now Q, sandstone, okay. Now where do we use sandstone? See, sandstone, okay, you must have observed in many constructions, we use it for your cladding elements and roofing elements, okay. So roof tiles or cladding tiles, they are made with your sandstone, okay. So tiles for roofing, okay, so that is made from sandstone, okay. Next we have laterite, okay. So laterite basically has a very rough texture, okay. So laterite we generally use it for rough stone work because of its rough texture, okay, uneven texture, okay, and it has high permeability. Only for rough work of masonry we use laterite, okay. And finally slate, okay. Slate, okay, is a metamorphic rock, okay. So that metamorphic rock has very low permeability. Because of the low permeability, it is suitable for dam proofing and partition construction, okay. So because of its low permeability, we are using it for dam proofing, okay. So with that, okay, we have P is 4, sandstone is 3, hence option D, okay. Next, consider the following statements regarding the characteristics of poor lime, okay. Now what is poor lime? See, poor lime is defined as lime where clay impurities are more than 30%, okay. So if the lime has clay impurities more than 30%, the lime is called as poor lime. Now where do we use poor lime? Only for temporary and unimportant structures. What is the problem with poor lime? See, it slakes very slowly, okay, because of high clay impurity content, slaking is very slow, okay, and the rate of strength gain is also very poor, again due to high clay content. So look at the options. So regarding poor lime, it requires less slaking time and hydrates very fast. That is wrong, okay, because as we mentioned, due to high clay content, it slakes very slowly. Next, setting and hardening is very fast. This is also incorrect, because due to low lime content and very high clay content, okay, poor lime slakes, sets and hardens very slowly. Hence, option 2 is also incorrect. Only option 3 is correct, that is the color varies from yellow to grey. See, because of significant clay content, okay, the color is not white. Okay, fat lime, hydraulic lime, they are white in color, but poor lime, okay, the color varies from yellow to grey in color. Okay, so only 3. Consider the following statements regarding advantages of plywood. Okay, option 1. It has good strength both along as well as across the grains. Now this statement is incorrect. See, timber, any kind of timber, okay, when load is applied parallel to the grain, okay, it is very strong, it can take high amounts of load. If the load is applied perpendicular to the grain, okay, then the strength is less. Okay, so that is valid for all kinds of timber including plywood. Okay, so statement 1 is incorrect. Statement 2, see, it will not shrink or swell across the grain. See, a very important advantage of plywood for using it in furniture is that it cannot swell, it does not swell when it comes into contact with moisture. Okay, so statement 2 is correct. It can be curved into desired shapes, that is also correct. Okay, see, plywood, even with low thickness, it will have good strength. Now because of the low thickness, it can be bent into required shape and size. Hence, so in desired shape and size you can bend it. Okay, so curved surfaces can be formed. So 2 and 3 are correct, option C. Right. Match list 1 and list 2. Okay, so list 1 we have different type of civil engineering works. List 2, different types of timbers used for different type of timbers suitable for civil engineering works. Now for bridges, see, bridges, strength of timber is very important. Okay, so out of all these timber, blackwood or ironwood, they are very strong. So for bridges we use blackwood or ironwood. Okay, so just from that you can get option B. Okay. Now, scientific instruments, we use red cedar, satin or siso timber is used. For railway carriages, okay, we use this one, and for shuttering, guava can be used. So option D. Right. Consider the following statements regarding calcined clay. Right. Okay. Now, where have we heard about calcined clay? See, in Portland pozzolana cement preparation, okay, in the production of Portland pozzolana cement, okay, you must have heard about calcined clay. Okay, so how do we get PPC? We get PPC by intergrinding cement clinkers with fly ash or a mix of fly ash and calcined clay. That is how you get Portland pozzolana cement. Okay, now what are the properties, basic properties of pozzolana cement? Okay, it has low initial strength. Okay, it has low heat of hydration. Okay, rate of setting and hardening is slower compared to OPC. So just remember these points. We look at the options. Okay, now calcined clay, its chief function is to impart strength and hydraulic properties of mortar. Okay, so calcined clay, okay, it hydrates slowly, because of which, okay, you will get strength and hydraulic properties, okay. So it reacts with water, you will get good strength from that. So statement 1 is incorrect. It is dense, compact and impermeable concrete. See, use of calcined clay, okay, use of calcined clay will reduce the permeability of concrete. Again, that reason is due to slow rate of setting and hardening, less formation of micro cracks, hence statement 2 is also correct. Okay. Statement 3, it increases the temperature of hydration and sets the concrete quickly, that is incorrect. Okay. See, calcined clay in PPC, what does it do? It reduces heat of hydration and delays the setting process. So this is incorrect, only 1 and 2 are correct, option B. Okay, what are the concrete stages? What are the concrete stages production order respectively? See, so in concreting, what are the different order of stages? So for concreting, first is batching. Okay, so we measure and proportion the ingredients as per requirement. Then mixing of ingredients. Okay, all the ingredients are mixed as per the desired proportion. Then transportation of the prepared concrete. Then placing of the concrete in the formwork. Then we do compaction, that is removal of any air voids present in concrete. Okay. Then curing and finishing. Okay. So then we will go for curing, okay, with specified number of days as per the cement used, and finally finishing the surface to protect the concrete surface from any kind of environmental effects. So option D. So that is the order in which concreting is done. Consider the following statements regarding functions of admixtures. Another question on admixtures. Okay. So what does admixtures do? Okay. In general, it is to speed up the rate of development of strength at early ages. Now this is correct. Certain admixtures like calcium chloride, they are called accelerators. Okay. They improve the early rate of strength gain of concrete. So statement 1 is correct. It increases the strength of concrete. See, because of the use of certain admixtures, okay, your plasticizers, super plasticizers and accelerators, okay, there is some increase in strength of concrete. Okay, so concrete strength can be increased using admixtures. It increases the heat of evolution and decreases the durability of concrete. This is incorrect. See, admixtures are used to enhance the properties. Okay, so we will never use an admixture which will deteriorate the properties of concrete. So here, increasing the heat of evolution and decreasing the durability are undesirable. So we will never use any admixture which does that. So statement 3 is incorrect, option C. Next, consider the following statements regarding concrete mix design. Okay, so what are the different elements involved in concrete mix design? First, it is to be compressive with, okay, there is some, okay, grammatical errors are there, okay, bear with me. So here we use, see, in concrete mix design, compressive strength has to be determined as per standard test specimens. So that is correct. It is to be compiled with the durability requirements to accept the environment. So that is also correct. So based on environmental requirements, okay, so you had to choose the correct grade of concrete, okay, cover thickness, etc. So grade of concrete, okay, selection of grade of concrete, okay, and minimum cement content requirements, okay, they come with the durability requirement as per the environment. That is also covered in concrete mix design. Okay. It is to be capable of mixed, transported and compacted as efficiently as possible. Yes, that is also correct. Okay. See, in concrete mix design, you have to make sure that the mix has the desired workability. Okay. So with the desired workability, okay, your concrete can be mixed, placed, compacted and finished properly. Hence, you have to take that into consideration as well. So workability requirements, so this third statement is about workability requirements So that is also dealt with in concrete mix design. So all the three statements are correct, option B. Next. Consider the following statements regarding the design requirements of concrete mix. The grade of concrete M20, M25 connotes the characteristic strength 30 and 35 Newton per mm square. That is incorrect. See, what is M20? M20, in M20, M stands for mix, 20 is the characteristic strength. So M20 characteristic strength shall be 20 Newton per mm square. For M25 it should be 25 Newton per mm square, not 30 and 35 respectively. So this is incorrect. Now, type of cement. See, concrete mix design is independent of the grade of cement. Okay, so the grade of concrete which you get is independent of the grade of cement which you are using. So 33, 43 and 53 grade. Okay, any type of cement can be used. Okay, so this is correct. Type of mixing and curing water. Okay, whether fresh potable water, sea water, ground water is to be used. See, in concrete mix design, okay, so the water requirement, fresh water can be used, sea water can also be used, okay, for mixing and curing, groundwater can also be used. So here statement 1 is incorrect, 2 and 3 are correct. Option B. Next. Consider the following statements regarding characteristics of good mortar. Okay. So what are the characteristics of a good mortar? Okay. First, okay, the density and strength of mortar made of the same class of aggregate decrease as the proportion of fine aggregate is increased. Okay. See, the density and strength of decreases with as the proportion of fine aggregate increases. That is true. Okay. See, mortar, okay, we have three ingredients: cement, fine aggregate and water. Okay. As you increase the proportion of fine aggregate, okay, the cement proportion in the overall mix decreases. Okay. And we know strength and durability of mortar depends on proportion of cement in the mortar. So as you increase fine aggregate proportion, strength and durability of cement or cement mortar reduces. Okay. So statement 1 is correct. It requires twice as much cement to produce a mortar of given strength when fine sand is used as it does with coarse sand. Now, this statement is incorrect. Okay. See, strength of mortar depends only on the proportion of cement in the mortar mix. Okay. It does not depend on fine aggregate. So whether your fine aggregate is fine sand or coarse sand, okay, it has no effect on strength of the mortar. Strength of mortar depends only on the proportion of cement. If the proportion of sand is fixed or fine aggregate is fixed, whether it is fine sand or coarse sand, it does not matter. Okay. So statement 2 is incorrect. Okay. Right. Even small percentage of mica, if present, considerably increases the tensile strength of the mortar and adversely affects the compressive strength. Now, the statement is correct. Okay. So mica, naturally occurring mineral. Okay. If it is present in excess in mortar, okay, mica we know it has plates, it has a layering texture, okay, because of which tensile strength increases, okay, mortar tensile strength increases, but okay, compressive strength of the mortar decreases. So statement 3 is correct. So 1 and 3 are correct, option C. Right. Okay guys, so that was about building materials. So overall 16 questions were there. Okay, relatively easy, just by elimination most of the questions could have been answered. Okay, thank you. So dear student, so coming to CPM and PET, that is concession management subject. So there were 8 questions. There are 2 numericals, the rest of the questions are only theory based. We could not see any question related to CPM and PET. Of course, this subject is known as CPM and PET, but there were no question from CPM and PET, only concession management. So this question is related to specifications. So which one of the following is not a necessity of specification for construction? If you see the options, straight away we can take option D, no need to read the remaining statements. Suppose if you look at statement D, that is option D, specification has no impact on changes of cost of materials and tender rate. Actually specification will decide the rates and everything. So specification has no impact to mention. So I can choose directly straight away without any thinking. Option D is because you have to find out not necessary. Next, this is a numerical. Capitalized value, just simply remember what is the capitalized value. Capitalized value is equal to CV is equal to A divided by I. This is a fundamental formula. What is A in this? A is nothing but annuity or yearly amount or yearly income. So what he has given 800 per month. So rent amount is equal to 800 and in that outgoing amount is equal to 18%. So 18% is getting out from that 800 rupees. So what is the net revenue, monthly net revenue is equal to what we can write. So this can be written as 800 into 18% if you remove, no, then it is equal to how much it is, 600 like 0.82, only 82% I am taking, 18% outgoing. And what about months, how many months? 12 months. This is actually A value. I value, rate of interest mentioned here. 8%, so we will write 0.08. If you simplify this, it is around 98,400. Directly we can choose the answer. Option A is the right answer. Just don't bother about the 60 years and all, because building life is equal to more than 50 years means it is a long life, and the capitalized value always A by I. Next, lump sum contract. In case of lump sum contract, in the beginning itself all details are well specified. So all details like specifications, drawings, designs, BOQ and everything is specified well in advance, and the money value also fixed in the before execution of the contract, before execution of the work. The project owner knows very well as well as contractor knows very well. If anything happened after execution, maybe during execution any deviation, who is going to bother? Only contractor. It is not the headache of client or owner. So answer is option A. In case of unforeseen hazards, who is going to take care? Only contractor will take care, because in the beginning itself already project cost is decided. Next question, this is related to when the contractor can stop the work. Actually the contractor can stop the work in case if any court order, so there is a legal litigations and disputes, and even most of the cases because of legal issues court will give the stay order. If the work is stopped by court order, so this is correct. In case of court order, like everyone has to stop, even the contractor can stop the work. If the architect fails to issue the certificate of payment in the stipulated period, actually the architect is only connected with the owner and is only a liaison officer and he is no way concerned with directly to the contractor, so this is not mandatory. And if the owner fails to pay the contractor after the stipulated period or certification for the payment, if the owner is not paying money, then obviously what the contractor will do, he will stop. So what about answer here? 1 and 3. Where we have 1 and 3? Option C. So next 10 meter cube brick work, just simply you remember 1 meter cube is equal to how many bricks required? It is just layman approach, 500 bricks. Just don't do any calculation. 1 meter cube is equal to 500 bricks. How many meter cubes? Like 10 meter cubes. So 10 meter cube, how many? So you can multiply with this. 10 into 500, how much it is? 5,000. Answer is option B. Here this is related to essential record or essential insurance. Generally in construction sites, any problem like hazards, or it could be even the workers are getting some health issues or accidents. In such cases, there is a need of some insurance policies. As per even any, it could be CPWD or even MES or any FIDIC norms according to even Indian Construction Contract Act, and Government of India has some rules and regulations. So in that insurance policy is mandatory. Coming to the first statement, workmen's compensation and employers accountability insurance in accordance with applicable laws. This is actually mandatory. One is compulsory required. And the second one, comprehensive general liability insurance to cover any solitary whichever body the property should be maintained. So this is also mandatory. Comprehensive general, it is actually the responsibility of the project contractor as well as owner. Comprehensive automobile, actually comprehensive automobile is required where construction machinery is required, but it is not mandatory. So the third one is not mandatory, it is depending upon the situation, depending upon terms and conditions. So answer is 1 and 2, option B. Option B is the right answer. Next question, here this is a numerical related to number, size of sample. Okay, for size of sample there is a standard formula, n is equal to z square into sigma square divided by E square. This is a standard formula, and one more formula is there, n is equal to z square into p into 1 minus p divided by E square. So depending upon the situation we can use the formulas. If standard deviation and error value given, then you can make use of the first formula. If standard deviation is not given, only proportion of work and proportion of not working given, then you can use the second formula. But right now we have standard deviation value given. What is standard deviation value here? 1.8, and the error value is equal to range they mentioned 0.5. So you can substitute n is equal to z. 95% z value is equal to 1.96. So 95% z value is equal to 1.96 standard. If it is 90%, is around 1.65. 99 means it is 2.57. But right now 95% mentioned. You have to remember this 1.96. 1.96 whole square into sigma square. So what is the sigma value as mentioned? 1.8 standard deviation whole square divided by the range he has mentioned, error 0.5 square. On simplification we will get n is equal to 50. This you can do the calculation, without calculus also we can do this. Next question, a preliminary survey indicates that 20% of time working. So 20% of time working means P is equal to 0.2, and not working 1 minus P is equal to 0.8, and 95% confidence level. 95% confidence level means the corresponding Z value 1.96. And you have to find out number of observation. Number of observation, two formulas we had now. One is Z square into sigma square, but right now here P into 1 minus P divided by, here what is the plus or minus 5% E square. Just substitute the values. Z value 1.96 whole square into P value 0.2 into 1 minus 0.2 divided by E square. E square is equal to how much here? Plus or minus 5%, so 0.05 whole square. So on simplification we will get around 245 point something, so 246. Answer is option C. Okay. So that's all about this concession management. I hope you have performed well. It is only relative. Examination is only relative performance. You have not performed well, don't worry, because the paper is tough, means tough to all. So I wish you all the best.
Dear friends, let us discuss hydrology questions. Which one of the following precipitations results from ocean air streams passing over the land deflected upward by coastal mountains? Coastal mountains. So the answer is orographic precipitation. C is the right option for this question. Which one of the following terms refers to the time between the end of the net rainfall and the end of the direct runoff hydrograph? Is the direct definition is the time of concentration Tc. D is the right option for this question because it's the end of the rainfall and the end of the direct runoff hydrograph. So definition for time of concentration is this. Match the following lists. Soils are given, infiltration rates are, these are data based questions only. That is pure theory based questions. We know pretty well bare clay will have the least infiltration rate, that is 0 to 4. See S2, where is S2? Luckily we got S2 is only one combination, that is C is the correct option. C, bare clay will have the least infiltration rate. Highest moisture holding capacity implies least infiltration rate. C is the right option for this question. Match the following lists. Wooded area, gravel roads, magdamizer roads and watertight roof surface. This is also, if you remember one point clearly, watertight roof surfaces, they cannot absorb water. Every drop of rainfall will get converted to runoff. Definitely runoff coefficient is maximum. So watertight roof surfaces, runoff coefficient is maximum 0.7 to 0.95. Yes, we are lucky. Yes, 1. Yes, 1. You are very, very lucky. Yes, 1. So B is the right option for this question. When the surface is watertight, no absorption, no infiltration, every rainfall will get converted to runoff. Runoff coefficient is maximum. What is runoff coefficient? Runoff divided by rainfall. Friends, B is the right option for this. Consider the following statements regarding groundwater. Groundwater is exhaustible, wrong. Natural replenishment of groundwater source is very fast. Dam, wrong, that is slow process. Groundwater is generally better than surface water in respect of biological characteristics. Only 3. Only 3 is the right option. Only 3. So 117 question, answer C is the right option. Match the following lists. Specific yield, specific limestone will have least value of specific yield. Yes, 3. Then we have clay. Clay will have 15 to 25%. So S3, where is S3? We got this and this. So you have to see the other one. Sandstone will have intermediate value 15 to 25. Sand and gravel 1 to 10. So therefore C, this is 4, 2, 1, 3. So D is the right option for this question. A fully penetrating artesian well is pumped at the rate of Q. As asked, what is the drawdown at the distance? We know the formula for a drawdown. Q divided by 4 pi T WU. Q is given, units are important friends, 1500 meter cube per day. Remaining terms also we must convert in terms of per day. 4 pi, 4 into 3.14 into T. Transmissivity value is 0.145. 0.145 meter square per minute. We have to convert per day. Multiply with 60, you will get per hour. Multiply with 24, you will get per day. Meter cube per day divided by meter square per day. W value directly given 8.62. If you simplify, you will get the value nearly 4.93. The correct answer, if you calculate, you will get the correct answer as 4.93 meters. Only 2 steps in the solution. One is the remembrance of the formula. Second one is careful about the conversion of the units. Day, minute. If you remember those two, the problem is simple. Water attached to the soil particles through loose chemical bonds, simple hygroscopic water. The water remaining in the soil after the removal of the gravitational water is dash. Once the gravitational water is removed, you will get the status of the field capacity. So D is the right option for this question. From this question, 91 to 95 questions are from irrigation engineering. Field capacity and permanent building point are given. 35% is the field capacity, 10% is the permanent building point. PWP is not necessary for us because water is supplied to the field when the moisture content is 20%. So how much water is supplied? Y supplied is equal to S into D into Y to be supplied, S into D into Fc minus moisture content at this moment. Specific gravity 1.6, root zone depth 0.8 meter, water depth is given millimeter, convert कीजिए 0.8 meters into millimeters by multiply with 1000, field capacity 35%, the moment where the water is supplied to the field is 20%, 35 minus 20 in percentage by 100, 100,000 मारो 10 times, 1.6 into this is 8 into it is 15, 120 into 1.6 that is 192 millimeters. कितना सप्लाई किया गया 250 millimeters सप्लाई किया, Y supplied 250, कितना सप्लाई करना चाहिए था 192 millimeters. Percentage water wasted by the farmer, percentage water wasted, सप्लाई किया 250, सप्लाई करना था 192 डिवाइडेड बाई 250, परसेंटेज में बोलने के लिए मल्टीप्लाई विथ 100, इट इज 58 by 250 multiply with 100, 50 into 2, 50 into 5, this is 11.6. So simply you will get 23.2%, almost 25% water is wasted by the farmer because he doesn't know the formula of irrigation water to be supplied. Match the following lists. Clay, sand will have the, what are the different field capacity values? Clay will have the field capacity 5 to 10. Clay will have the maximum moisture content 30 to 40. Sand will have the least moisture content 5 to 10. Loam will have 18 to 25, actually 15 to 25, 18 to 25. Silty clay will have 27 to 35. Clay will have maximum 30 to 40. When silt is added to clay, somewhat reduced, that is you are going to get 27 to 35. Loam is 18 to 25, least value is sand, P1, Q3, R2, S4, P1, Q3, R2, S4. B is the right option for the given question. The formula given by Molitor, two equations when the fetch is less than 32 kilometers, 0.032 root VF plus 0.763 minus 0.271, fetch to the power of 1 by 4, D is the right option. HW in meters, V in kilometer per hour, fetch in kilometers. Here one small printing mistake is there in the question paper, has asked what is the formula for the variation of horizontal hydrodynamic earthquake pressure. Horizontal earthquake pressure is given by C1 into alpha H into W into H. W is not given directly, mass density and G are given, C1 alpha H rho G H. Formula, here rho is missing friends, with rho, add rho here, correct formula is this. When you see the answers, C is the right option, the small printing mistake from the side of the paper setters. These are the questions on hydrology and irrigation. I hope you fared well. I wish all the best. Good luck to you. Next faculty member will come.
Good evening. So, ESE 24 Civil Engineering, my part is construction equipment and hydraulic machinery or machines. Let us start with the construction equipment. There are 2 questions given. One question is on cranes. Second question is on the way we handle concrete mixer. Mixer to the dumper, nothing but conveying equipment, how it is handled, what are the conditions for that, like that. Hydraulic machinery, we know turbines and pumps. Let us start with the question pump construction equipment pertaining to crane. We know very well the crane, how it works. Crane has the craveler part on which the body is mounted. Inside the body, equipment is meant for the hoisting, and the boom is extended, a pulley is mounted, and the hoist rope is passing over the pulleys and carry the load. Okay? So, related to that, there are 3 statements, and you have to read the statements and answer the correct true statements. The size of the craveler, we know very well craveler. Craveler nothing but the way the whole crane is mounted on it. So, these are the counterweights. So, this is the boom, this is the pulley, this is the load, and this is the hoist mechanism, this is cabin. We have studied this way, right? Now, let us see first statement. The size of the craveler is not a factor to limit mounting which decrease stability. No, it is stability means the load and the angle, the extent of the boom and all, this is stability. Suppose something is change, radius of the boom change or angle of inclination of the boom change, that can make the crane to unstable. So, this is the meant for holding the equipment. This will come into picture while craveling, nothing but while running equipment from one place to another place. So, statement 1 is correct, not a factor for stability. Second statement, strength of the boom, we know very well boom made from steel structure elements, welding, fabrication, riveted, nut and bolt. This is the truss, a framed structure which is pivoted at one end and it is supported by other mechanism, mast mechanism. Okay? By changing radius, by changing angle, the load carrying capacity change. This is the understanding. The strength of the boom also one of the major governing factor in establishing load rating. This is load rating. Any extension of the boom reduces rating. Yes, when you increase the radius, load carrying capacity decrease. We know that very well. Movement of the forces about the hinge point or about the turning point. Lowering the boom means angle decreases. Lowering the boom increase the clearance radius. Radius increase, load decrease. This is also correct. Next, counterweights. These are called counterweights. Counterweights meant for balancing the stabilizing the equipment under heavy load. By putting the counterweights with appropriate maximum load, we can make it a balance of the force. If counterweights are not properly loaded, it can overturn. We can observe in the spillway of the dams where we have various cranes there, mast cranes. Okay, say that we have discussed in separate subject, design point of view. Now here, equipment point of view, the counterweight is added at the after end of the machine, nothing but crane. The manufacturer specifications provided a standard counterweight corresponding to maximum or load carried. So, counterweight may be increase or decrease depend upon the loads we permitted. So, as per the statement 3 also correct, answer. So, let us see again size of the craveler. Let us see again the problem. All statements seems to be correct, but only limited is given. The size of the craveler, okay, is not meant for stability of the load. It is meant for the moving of the equipment. Okay, so this is correct. So we can make it this one because 3 given, well and good. Not 3 given now. So restricted our knowledge now 2, 2 and 3 perfectly correct. So answer D is permitted. So why it is? The size of the crawler equipment we discussed with reference to moving stability, not the load carrying capacity. But the way is the question given, only select the 2 statements, accurately 2 and 3 statements, right? Okay, clear. So if at all given with respect to load carrying capacity, okay, it's not much. Maybe increase, decrease the gap between the tracks, that manufacturer's design, not the user design, right? Next, in conveying most building concrete from mixer or truck to the workplace, nothing but farm work. Bottom dump truck, the cheap danger conveying the concrete. Definitely, concrete made from different materials. So definitely segregation is a problem. Okay. So it's not the time is we know 1.5 hour, the shifting time and all. The question is that concrete collected from the mixer or this one, dumped in the dump truck, traveled to the work spot, farm work, there we dumped. So in between the way it is different components of the mixer affected segregation. These are 2 questions related to construction equipment. The next subject is hydraulic machines. Hydraulic machines, 2 types, hydraulic turbines, hydraulic pumps. Let us see, there are 5 questions given from hydraulic machinery. Which one of the following head is defined as head against which? The pump has to work, manometric head, very clear, answer D. So straightforward question. Consider the following statements with respect to positive displacement pumps. Positive displacement pumps, 2 types. Reciprocating positive displacement pump, rotary positive displacement pump. Rotary positive displacement, nothing but gear pump, vane pump, helical pump, this type of pumps. So the positive displacement pump is better able to handle shear sensitive liquids. Shear sensitive liquids mean nothing but viscous fluids, gear pump or screw pump or vane pump, correct. A well sealed positive displacement pump can create significant vacuum, definitely even at dry also. If it is centrifugal pump, not possible. We have to fill with the priming of the liquid and all. The rotor of positive displacement pump, here mentioned is rotor, not piston, not plunger. That come into picture reciprocating. Rotor of a positive displacement pump, nothing but gear pump, helical gear pump, spur gear pump, say screw pump, vane pump, such pumps called rotor positive pumps. They run at 10,000 RPM, 15,000 RPM, whereas impeller of the centrifugal pump is 2,000, 3,000, 4,000, 1,500, 1,440 standard. The speed of the centrifugal pump less than speed of the positive displacement pump. This also correct. So all are correct. Okay, 1, 2, 3 are correct. Say answer D correct. D answer. D answer, right? Next question, third question. Consider the following statements with respect to draft tube. We know very well, draft tube is used in reaction turbines, not in impulse turbines. Draft tube is meant for connecting the outlet, nothing but exit of the reaction turbine like reaction, Kaplan, propeller to the tail end. It is meant for converting kinetic energy of the exit of the water from the turbine into the potential energy. It permits to keep the turbine above the tail rise. So affecting head increased. So effectiveness, efficiency improved. Okay. So gross head increased. So that way it permits suction head to establish at the runner. Yes. Exit of the reaction turbine can be below atmosphere. So suction pressure possible at exit of the reaction turbine, nothing but inlet of the draft tube. Statement 1 correct. It makes possible to install turbine above the tail race. Yes, draft tube permits to keep the reaction turbines above the tail race. This also correct. It converts large proportion of the velocity energy rejected from the runner into useful energy. This also correct. So answer D correct. All are functions of the draft tube. So simple. Consider the following statements with respect to regarding Kaplan turbine. We know very well. Kaplan turbine consists rotor, so hub, and extended adjustable rotor vanes or blades, right? What we say that. So these blades are twisted. The twisted word nothing but wrap. Okay, this is correct. Runner blades of Kaplan turbine are wrapped, nothing but twisted. Okay. The blade angle being greater at hub than the outer tip. Yes, because of the twist, the angle at inlet of the hub is greater than the outlet. So angle at hub to tip keep on decreasing. This also correct. The peripheral velocity nothing but u is equal to r into omega. So u is equal to r into 2 pi n by 60. For the given speed, tangential velocity nothing but peripheral velocity directly proportional to radius. This also correct. So D. All statements are straightforward statements. Next, last question, fifth question from the hydraulic machinery. Match the following. So list 1 is given specific speed range, list 2 given the type of turbine. We know very well, low specific speed turbine pertaining belongs to impulse turbine. Impulse turbine nothing but Pelton wheel up to 30 Pelton wheel with single jet, 30 to 55 Pelton wheel with multi jet. So P goes to 3. Now medium specific speed range nothing but Francis turbine, modern Francis turbine, range from the 50 or 55 to 340. Here we discuss in classroom 300. So that is Francis turbine. High specific speed turbines nothing but propeller turbines, Kaplan turbines more than 300. Here given 225 to 860. Definitely it goes to 2. 312. Okay. So this is the way construction equipment 2 questions, 5 questions hydraulic machinery completed. So all the best, good luck for everyone who has written examination.
Okay, no? Yeah, good evening friends. Coming to the strength of material, this time we have slightly difficult and lengthy questions we are facing. Last 5 to 6 years if you are comparing, this time we have a slight difficulty. And look at the questions. First question from the strength of material. This is a standard result. What is the maximum deflection for the cantilever subjected to the UDL throughout? Yes, it is a straightforward questions. So maximum deflection for UDL in case of a cantilever, clearly we know del max, it should be equal to omega L to the power 4 divided by 88. Direct standard results. So option C is correct for this question. Let's move on to the next question. Let's move on to the next question. See this one. This is related to the shear stress distribution in case of beams. So assumptions are mentioned. See one by one statement. Consider the following statements regarding the distribution of shear stress. That assumptions. First one, first one, for all the values of y, Q is uniform across the width of the cross section irrespective of its shape. Perfectly. This is correct assumption. Second assumption, dm over dx is derived from the assumption that bending stress varies non-linearly. This is an incorrect statement. This is incorrect. And come to the next one. The material is homogeneous and isotropic and the value of E is the same for tension as well as compression. Perfectly. This is one of the basic assumptions that we are using in case of bending. This is correct. But if you are observing the statement, which of the above statements is incorrect? Now, this is correct statement and this is correct statement. Only 2 is incorrect. 1 and 3 are correct statements. Option C is correct for this particular question. Now, let's move on to the next question. Which one of the following statement is not property of the curves? Basically, it is related to the trajectory curves, stress trajectory curves that we discussed in principal stresses and strains. See the first one, property, not property. This is very important. Out of 4 statements, which is not the property of the trajectory curves, that is asking. Both the systems of the curves cross each other at 45 degrees. That is a principal tensile stress trajectory and the compressive stress trajectory. Both curves are not both are crossing each other at 45 degrees. This is absolutely wrong. Maybe or may not be correct. This is false statement related to the property. Now look at the next one. Each system crosses the neutral axis at 45 degrees. That is both principal tensile stress trajectory and the principal compressive stress trajectory, they are crossing at neutral axis exactly at 45 degrees. This is the correct statement, correct property. At any point of the curve, the tangent and normal give the direction of the 2 principal stresses. Exactly when you try to draw the normal as well as the tangent, one it is representing the direction of the principal tensile stress, other one it is representing the direction of the principal compressive stress. Yes, this is another property. And anyhow 4th statement is also correct. But here asking not a property of the curve. Option A is the not property of the trajectory curves. Let's move on to the next question. This is some calculated calculations required for us. See the question. A beam 3 meters long simply supported at its ends carrying a point load W at its midspan. So given beam is a simply supported beam. Given beam is a simply supported beam, length is given as 3 meters and it is carrying a point load W at its midsection, clearly mentioned. If the slope at the ends, suppose let me take this is also a standard case, slope at the ends in this case we know it is WL square divided by 16 EI, it is mentioned as 1 degree. Just I am taking this in terms of radians, yes this is we are having in terms of radian. And what we required the deflection at the midspan, that is the maximum deflection. Let's say maximum deflection in this case we know it is WL cube divided by 48 EI. Just to relate these 2 conditions, then you are getting the final answer. So this one I can write it as WL square divided by 16 EI, rest of the term is EL by 3. This value we have 1 into pi upon 180 radians and L value mentioned as 3 meters divided by 3. Just you can simplify, you are getting the answer in meters, that if you convert into millimeters, yes option we are having this is 0.01745 meters we are having. So when I just taking this in terms of millimeters, we have it is 17.453 millimeters. So which option is correct? Option A is correct. Look at here, option B it is given in terms of centimeters. Be careful. Option A is correct for this problem. Let's move on to the next question. Again, it is related to these statements are related to the properties of the conjugate beam method. Consider the following statements regarding the end conditions and the internal conditions of a conjugate beam we are having. Let's see the first statement. A stable statically determinate real beam will have a conjugate beam which is also stable and statically determinate. Exactly, this is correct statement. That is correct statement. And come to the second statement, an unstable real beam will have statically indeterminate conjugate beam. Hence, if a conjugate beam is found to be statically indeterminate, it is concluded that the real beam is unstable and further analysis is not appropriate. This is the extension statement for the given one. This is more important for us. An unstable real beam will have statically indeterminate conjugate beam. Perfectly right, this is. This is correct statement. And come to the third statement, a statically indeterminate real beam, look at here, this is very close to the second statement, will have the stable conjugate beam. So this is incorrect. It is having unstable conjugate beam, but given as a stable conjugate beam, this is incorrect statement. Now, when I am taking the question, which of the following above statements is or correct? Asking the correct statements for us. So here 1 and 2 are the correct statements. So option C is correct for this question. Option C is correct for this question. Let's move to the next question. Again, which one of the following is not? Again, it is not an assumption of the impact loading condition. Generally, we are not dealing with the impact loading condition in strength of material. So it is having a restricted area. But again, look at these statements. We can easily answer this question. The falling weight sticks to the beam and moves, vibrates with it. This is absolutely not correct. Right? We never deal with the vibrations. No energy losses takes place. So this is one of the fundamental assumptions when we are dealing with the impact loading in strength of material. Even though a slight energy losses we are having, that we are not considering, we are neglecting it. So this is the property we are considering. So obviously the beam is linearly non-elastic. That is another assumption we consider in strength of material. The deflected shape of the beam is the same under the dynamic loading as well as the static loading. This is another assumption we are using when we are analyzing the impact loading condition on the beams. So here asking a not assumption. Not assumption is nothing but option A is correct for this question. Let's move on to the next question. Match the following clearly. So tin rods, beams, columns, trusses. Here some options are given clearly. So one by one you can take this one. Column, it is clearly, let me take this one. When I am taking the trusses, trusses are carrying both tensile and compressive forces. Column, this is the basic member that is subjected to the axial compressive forces, option 2. So fourth one is matching with, S is matching with 1 and R is matching with 2. S is matching with 1 and R is matching with 2. Look at here, come to this one, beam, it is a reinforced concreter. Fourth one, and P, again it is a bracing. 3, 4, 2, 1. 3, 4, 2, 1 we are observing at number B. Option B is correct for this question. Even though you are not aware about the tin rods and this thing, we can easily match it by looking at the trusses and the columns. So it is a straightforward question. Let's move on to the next question. So this is a directly standard formula question for tapered rectangular shapes clearly. Look at here, which one of the following is the equation for the expression of the whole length of uniformly tapering rectangular bars where B1 and B2 are the limits of the widths. B2 is larger than B1, clearly mentioned. Length is L, thickness is T, and the bar is subjected to an axial force P with the elastic module E. So we need to write down the formula for the elongation in case of tapered rectangular section. Look at here, if I am taking the first option, PL upon B2 minus B1 E into T log base E B2 larger width divided by smaller width we are having. This is a straightforward formula oriented question. So option A is correct for this question. Let's move on to the next question. A conical bar tapers uniformly from a diameter of 15 millimeter to a diameter of 40 millimeters in a length of 400 millimeters. Again, it is a circular tapered bar. One end it is 15, other end it is 40. Let's say D1 is given as 15 and D2 it is given as 40 millimeters over a length of 400 millimeters. That's fine. What is the elongation of the bar under an axial tensile force of 100 kilonewtons? P value is given as 100. It is a direct formula oriented question. We require a simple calculation for this. And Young's modulus for this given as 2 into 10 to the power 5 Newton per mm square. And del L, if you take this one for tapered section, 4PL we know divided by pi E d1 d2. Just substitute all the values. So 4 into p value, it is given as 100 into 10 cube, length is mentioned as 400 millimeters, pi, Young's modulus value is 2 into 10 to the power 5, and d1, d2 are 15 and 40. Just to simplify, if you are simplifying, final answer what we are getting is so final answer 4 divided by 3p I am getting. So it is approximately 0.4244 millimeters, my dear friends. Look at the option, 0.424 millimeter we are observing at a C. C is the correct answer for this question. Let's move on to the next one. For this also we require a small calculation part. This is from temperature stresses, but direct question we have. A circular section tapering bar is rigidly fixed at both ends. The diameter changes from 75 millimeter at one end to the 150 millimeter at the other end in a length of 1.2 meters. What is the maximum stress in the bar if the temperature is raised by 32 degrees Celsius? Young's modulus value is given, alpha is given. So in this particular case, first we have to find out the p value, asking clearly the maximum stress. Stress may not be uniform throughout the length of the bar in this particular case, being it is a tapered section, we know it. So stress is maximum at a minimum cross section, that is at a here. So when you try to increase the temperature, obviously it will give the reaction at the supports. These reactions are same at both ends. So my target is by using the compatibility condition, first you need to find out the P. Once I have the P, then sigma max equal to P divided by A min. So what is the P value we are having from this one? Let's see. P we have, it is pi E alpha del T d1 d2 divided by 4, my dear friends. Area, if I am taking this one, area, this is d1 I am taking. Minimum diameter side I am taking d1, and a larger diameter side I am taking d2. Then sigma max, if I am taking this one, P value pi E alpha del T d1 d2 divided by 4 into area pi by 4 d1 square. Just you can simplify it. If I simplify it, I am getting E alpha del T into d2 divided by d1. Everything is there, E is available, alpha is available, del T is available, d2 is available, d1 is available. Just you substitute all the values. Finally, the outcome we have 153.6 Newton per mm square. So option D is correct for this question. Let's move on to the next one. Again, this question from temperature stresses. This time they are giving more importance for the temperature stresses. Again, this is related to the hoop stress due to the temperature changes. Directly we know the formula for this one. Sigma C equal to E into D minus D divided by D. Already we know it. A thin type of steel is to be strung on a rigid wheel of 900 millimeter. Capital D, it is a 900 millimeter diameter. What is the internal diameter of the tire if the hoop stress is limited to 120 Newton per mm square? So this is 120 given. Young's modulus is 2 into 10 to the power 5, and D value is given as 900 minus D divided by D minus 1. Just you can simplify that. The final thing we are having, this is D. How much we are having is 899.460 millimeters, my dear friends. 899.460 we are observing at option A. So A is correct for this question. And come to the next one. Again, this question from temperature stresses we are having, this time related to the composite sections. A solid cylinder of steel is placed inside a copper tube. The assembly is compressed between rigid plates by the forces P. What is the value of increase in temperature so that all the load is carried by the copper tube? Just use the compatibility condition. So from the compatibility condition, we know free expansion should be equal to expansion prevented in both bars. Just you can write down the compatibility. When I am writing the compatibility, L alpha del T for copper plus L alpha del T for steel equal to PL upon AE for copper plus PL upon AE for steel. Without using this also, by seeing the options, we can easily pick the answer. Option D is correct for this one. Now look at here. There is no load taken by the steel. Put this as 0. LL is getting cancelled. Del T equal to alpha C plus, sorry, this is minus alpha C minus, this is minus alpha S equal to P divided by AC EC. This term you can bring this side, then you are having the del T value, del T P divided by AC EC alpha C minus alpha S. So option D is correct for this question. Without seeing, just you observe the units, then I can easily pick the answer. Option D is correct for this question. Let's move on to the next one. Asking the Young's modulus value for various materials. Just you can observe it. So steel it is around 190 to 210. So aluminum it is around 65 to 70 we are having. And look at the next one. Wrought iron approximately is 190. So steel is matching with 2. S is matching with 2. Here and here, this is ruled out and this is ruled out we are having. And copper around it is 110 to 124. Copper R is matching with 4. Option D is correct. Just you can verify it simply. Rest of the things, aluminum it is P, it is matching with 3. Cast iron approximately it is right 83 to 170. 3, 5, 4, 2, 1. This is 1. That's it. Option D is correct for this question. Let's move on to the next question. Consider the following statements regarding the difference between the true strains and the engineering strains. Comparison is given. True strains for equivalent amounts of deformation in tension and compressions are equal, including for sign convention. No, absolutely it is incorrect. True strains are additive for a deformation consisting of several steps. The overall strain is the sum of the strains in each step. Absolutely, this is the basic definition of the true strain. This is correct statement. The volume change is related to the sum of the 3 normal strains for constant volume. Perfectly, this condition only we can use in a strength of material. Algebraic sum of the normal stresses when it is perfectly equal to 0. So which of the option is correct? So second and third are correct statement. Option C is correct for this question. Next one, see the properties are mentioned. Next question, consider the following statements regarding the properties of the materials. See the first statement, a material in a plastic state is temporarily deformed by the application of load and it has a tendency to recover. This is nothing but an elasticity property, but given as plasticity. So it is incorrect. Ductility is the characteristic of a material to be drawn out longitudinally to a reduced section, that is a duct section under the action of tensile force. This is perfectly right. And look at the third one. Malleability is a property of the material which permits the material to be partially extended in all directions. No, this is incorrect. So which is correct one? Second only the correct one. Option B is correct for this question. This question is related to the Mohr circle. Which one of the following statements is correct regarding the Mohr circle of a plane tensor? Sigma is positive in tension, that only we can mention, and it is plotted right side of the origin perfectly. Compression is negative, it is plotted left side of the origin. This is correct. Asking which one of the following is correct regarding this one. Tau is plotted negatively if it is rotated stress block in a clockwise direction. Clockwise shear we are taking as a negative, anti-clockwise shear we are taking as a positive. That is also correct. Angles theta from one axis to another around the origin or in different directions. Perfectly. Theta it is representing the different planes that are passing through the point. Any orthogonal set of axes are 90 degrees to one another on Mohr circle. No, they are double the angle. It is 180 degrees. So this is incorrect. Asking the correct statements we are having. These are the questions we are having from the strength of material. Hope all the best for our future.
Now, let's come to the surveying questions. So, see this question, consider the following statements regarding aerial photography. Aerial photography has the ease with which topography of inaccessible areas can be detailed. Yes, this is one of the advantages. So, statement number 1 is correct. And in the case of the statement number 2, in aerial photogrammetry, there is a possibility of omitting a few data. No. In the case of the aerial photogrammetry, you cannot eliminate the data. So, statement number 2 is incorrect. The correct answer is option A, 1. Next, come to the question number 17, match the following. If you see, they have given the reason and corresponding the wavelength. If you observe, for the reflected IR beam, it is 0.723 micrometer, and for the Q, which is X-ray, which is going to be 0.0323 mm. So, from the given options, the correct answer is option B. Next, come to the question. If R is the radius of the circle and delta is the deflection angle, what is the formula? So, it's a direct formula. The correct answer is option A. Next, which one of the following type of equipment is used in the topographic surveys and also for recording the shapes of the building? For the shapes of the building and topography, so you have to go for the aerial route, which is aerial camera. Next, match the following list. Again, there is a direct formula. So, if you see the absolute length, the term that is related with the term is, for the P is a 3. So, if you see the options, the correct answer is going to be like for the P. So, P is equals to 3, and for the Q it is going to be 2, which is going to be nothing but h square by 12, and correct answer is option B. Next, if the sensitivity of the bubble tube is 30 per 2 mm division, what would be the error in the staff reading? So, again it's a direct formula. If you substitute, the correct answer is 0.073 meters. Next, when a celestial body crosses the observer's meridian, it is said to be culmination. So, the correct answer is culminate. And why the observations of field astronomy do not involve the measurement of declination and right? So, they will not involve because the stars celestial observation will keep on changes. So, if you see the options, because the stars do not occupy the fixed position. So, the correct answer is option B. And now, if the equality of the backside distance and foresight cannot be maintained under such condition, which one of the following leveling? So, to maintain the backside and foresight, we have to go for the reciprocal leveling. The answer is option B. And now, the last question, consider the following statement regarding the global position system. GPS cannot be used in all weather conditions. No, GPS can be used in all weather conditions. So, which means the given statement 1 is incorrect. And if you see the remaining 2, the correct answer. So, if you eliminate A, C, D, and the correct answer is option B. And coming to this question, consider the following statements regarding remote sensing surveying. Different type of land use are distinguishable on images. No, you cannot see the different type of land uses. You can see the different type of lands. So, again statement number 1 is incorrect. If you go by elimination, option A is eliminated. But most images lack the horizontal perspective. Yes, that's a true. So, second statement is true. For surveys of the small areas, the cost of mobilizing a remote sensing mission may be uneconomical. Yes, obviously, for small areas, it is uneconomical. So, statement 2 and 3 is correct. The correct answer is option B. So, these are the questions with respect to the surveying. And next, you will be seeing the structural analysis and steel structures from Mallikarjun sir.
Now we will see structural analysis and design of steel structure. Okay, first we will see the structural analysis subject. So here match the following. So here cables always subjected to tension. Okay, so support their loads. Okay, so Q3. So you can eliminate B and C. Okay, next arches subjected to compressive forces. Okay, then R1. So then option A is correct. Next question, which of the following is the condition for maximum shear in a cantilever? Okay, in not given section, if in not given section, that is called absolute maximum shear force, right? Okay, so this is a cantilever beam, Okay, so where we'll get the absolute maximum shear force for a series of concentrated loads? For series of concentrated loads, this is the ILD for shear force at the fixed support. Okay, just load into ordinate will get the absolute maximum shear force. It means load should be near to the support. If the loads are near to the support, then only will get the maximum shear force. Okay, so near to the nearest point, then option C is correct. Next question, consider the following statements regarding the principle of superposition. Okay, here principle of superposition, first one, the total displacement of stress at a point in a structure subjected to several external loads can be determined by adding together the displacement caused by each of the external loads acting. This is not together, this is individually. Okay, then option 1 is correct, wrong. The next, the material must behave in a non-linear elastic, this is linear elastic. Okay, so 2 also wrong. Then only option is 3. Okay, then here option C is correct. Next, what is the condition for stability of truss? Here number of members are given B, okay, and number of reactions given R, and number of joints are J. Okay, so we have one formula, ds equals to, for trusses, m plus r minus 2j, but in place of m is given B, right? Okay, then here B plus r equals to 2j. Okay, so here if it is less than 2j, this is unstable, but here he is asking stable, so we can eliminate C and D. Okay, then either A or B, this is the condition for statically determinate structure, this is the condition for statically indeterminate structure. Okay, here statically determinate structures may be stable or unstable, statically indeterminate structures also may be stable or unstable. Okay, so here option A is correct, option B also correct. Okay, but most preferable option is A, right. Next, now we will see the steel structure. Okay, which of the following is not a factor in the design of tension member? I given formulas based on cross section yielding, based on net section rupture, and based on block shear failure. Okay, so based on cross section yielding, there is a cross section yielding, you will see the formula AG. Okay, then D is correct. Okay, in net section rupture or fracture, you will see length of connection, that is in the formula you will see LC, and type of fabrication, alpha values depends upon number of bolts and welded case. Okay, so this also correct, and eccentric connection, it means shear lag effect. Okay, then here 4 are correct. Okay, but here not a factor, so here 4 are correct, but will prefer option D because least it will reduce less strength. Okay, next, so this is the question directly from code book. Okay, if you see here, he asking maximum effective slenderness ratio. Okay, if you see member always subjected to tension, if member is always subjected to tension, then maximum slenderness ratio is 400. Okay, then here S2, so only one option is there, S2. Okay, so option B is correct. Okay, next, which of the following not a parameter for determining the strength of column? There is a lengthy formula is there to find the strength of column. Okay, you will see the terminologies, there is a material of the column, yes, and cross sectional configuration, yes. Okay, but in the formula you won't see the width of the column. Okay, and there is a residual stresses also, but he asking not, then option C is correct. Okay, next, consider the following modes regarding failure of axially loaded column. Okay, failure modes here joint buckling is not the failure mode. Okay, then eliminate 3, if we eliminate 3, then only one option is there, that is D. Next, so this is the directly question from steel, code book only. Okay, so option C is correct. Next, so here angles will use in purlins. Okay, then roll steel section generally will preferred in beams, and castellated beams are long span and lightly loaded, and plate girders, these are the long span and heavily loaded. So with only option C, plate girder S1, so only S1 is there for option C. Okay, next, consider the following statements regarding the lateral torsional buckling of symmetric section. Okay, these are the assumptions. Okay, so the beam has no initial imperfection. Yes. Okay, this is assumption correct. And it is loaded by unequal angle. No, this is equal angle. Okay, this is not unequal, this is equal angle. This is wrong. Next, the beam have residual stresses. Okay, the beam will not have. Okay, beam will not have residual stresses. This is assumption. Only one is correct, that is option D is correct. Only one. Next, which of the following is not a functional requirement of a girder? Okay, in girder, flanges are designed to resist the bending moment. Okay, and vertical stiffness to satisfy any deflection limit. Yes. Okay, and strength to carry the shear. Yes. Web is resist to shear only, right? Okay, then option D is wrong. So D is correct answer here. Okay. Next, last question. I mean, which of the following is not a difference between the behavior of beam column subjected to bending moment about minor axis to major axis? So this will take more time to explain these 4 points. Okay, so I am giving here directly option C. So in place of decreases, there is a increases. Okay, in place of decreasing, there is a increasing. Okay, option C. Next, in practical design of steel structure, on the vertical wall, external pressure coefficient, that is CPE. Okay, students, actually external pressure coefficient, it is depend upon height to width ratio and building plan ratio, but in the question it didn't give an height to width ratio and building plan ratio. Okay, so data is insufficient here. Next, consider the following statement regarding the behavior of a column under compressive load. Okay, so here stress strength properties do not remain constant throughout the length of the section. Yes, it is not constant, it will vary. Okay, next, residual stresses due to cooling after rolling the steel section and those imposed by welding during construction exist in the section. Students, before cooling, after cooling, there is some residual stresses. Okay, so this is correct. Here third one, due to construction details, the load is perfectly concentric. No, it is practically, loads are not perfectly concentric, there is a eccentric, and end condition will not vary from case to case. No, it is depends. Okay, it will vary. Then only 192. So only 192, the option A is correct. Last, what is the minimum load factor for dead load as per IS 800 1984? This is as per working stress method. Okay, it is 1.7. Option B is correct. Okay, so these are the questions from structural analysis and steel. Okay, next faculty.
Let us look at the questions that have come from fluid mechanics. Question number 1 is saying, consider the following statements regarding flow measurement through pipes. The first statement is, reduction in construction diameter causes the velocity to increase. That is correct, because if you decrease the diameter, area decreases, velocity increases, continuity equation says so. Statement 1 is correct. So option B and option C can't be your answers. Second statement says, high velocities in constriction cause low pressures in the system. Use Bernoulli equation over here, high velocity would imply lesser pressure. Statement 2 also is correct. That means the answer A over here is correct. I am not even going to read 3 because there is no point, because the option D does not consider statement 2. Moving further to second question, consider the following statements regarding ultrasonic flow meters. Now ultrasonic flow meters is very rarely used though. The first statement over here is, there are no moving parts. That is true, no moving parts. They cannot measure flow quantities in reverse flow direction. That is wrong. They can actually measure. They are having two probes and they are going to issue some kind of signal, and it can be issued in either directions. So this statement over here is wrong. The moment I identify statement 2 is wrong, I can eliminate over here these two options, rather three options. The only answer over here is, there is no point reading statement 3 now. So third option or third statement should be correct now. Moving further, the next question is saying, when the average flow is steady, which one of the following causes significant fluctuations in velocity, temperature and pressure? All of these things are pertaining to turbulent flow. Now what causes turbulence? Basically the cause behind turbulence happens to be the intermolecular collisions taking place because of the random motion of particles. So the correct answer over here is supposed to be molecular diffusion in turbulent flow. Moving further to the next question. The next question says, how does the bulk modulus of elasticity of a fluid change with increasing pressure? As pressure increases, the bulk modulus also is supposed to increase, and we know this thing, as we go deeper in seawater, bulk modulus will increase. So it increases with increase in pressure. So statement C is correct over here. Moving further, now this is a very fundamental question coming from stability of floating bodies. The question is saying, consider the following statements regarding stability of floating bodies. Statement 1 says, if the metacenter lies above the center of gravity or centroid, so M is above, G is below, GM is positive, stable equilibrium, but he is saying unstable over here. Statement 1 is wrong. The moment you identify it is wrong, you can eliminate A and D over here. Now statement 2 is saying, if metacenter lies below center of gravity, then body is said to be in unstable equilibrium. That is correct. M is below, G is above, unstable. This is correct. Now statement 3 is saying, if metacenter coincides with center of gravity, it is stable equilibrium. It is supposed to be neutral equilibrium. So this again is wrong. So the only answer over here is option C. 2 only is correct. Moving further to the last question, this is a direct formula. It is saying, if Vs is the velocity of the vector, velocity vector rather, and R is the radius of curvature, the value of and dou Vn by dou T is a local normal acceleration. What is the expression for total normal acceleration of a fluid particle? We are having one local quantity and one convective quantity. Convective quantity is supposed to be centripetal acceleration given by Vs square by R, and that is supported by option B. So these were the questions from fluid mechanics. Hopefully you were able to answer these questions, and all the very best to all of you. Thank you.
Okay, dear students, here I will discuss the questions from RCC. This year they have asked more than 50% of the questions from American court. If you see previous year questions, you don't find the questions from American court. Okay. Unluckily, this year they have given more than 50% of the questions from American court. Don't worry. We'll see the correct answers to the questions from RCC. Very first question. Which one of the following is the creep coefficient at any time? Where CCT is the creep coefficient at any time, and CCU is the ultimate creep coefficient, and T is the time in a days after loading. This one is a direct formula from American court. My dear, option A is correct. Moving to the next question. Consider the following statements regarding the design of T-beams. Here are given 3 statements. Statement 1, to establish plane thickness HF based on flexural requirements of the slab, which normally spans transversely between the perpendicular T-beams. But no doubt it is correct. Flange thickness is nothing but a slab. Flange is nothing but slab. The thickness of slab decided based on the bending moment. So statement 1 is correct. Coming to the statement 2, determine the effective flange width BF according to ACI limits. No doubt. We have seen effective flange width as per IS 456-2000. Similarly, as per American code also, there is effective width flange formula. So statement 2 also correct. Coming to the statement 3, choose web dimensions BW and D based on either negative bending requirements at the supports or shear requirements by setting a reasonable upper limit on the nominal unit shear stress VU in the beam web. No doubt statement 3 also correct. If you check American code, it is given very clearly. Statement 1, 2, 3 are correct. So option D is correct. Coming to the next question, what is the minimum thickness H of non-prestressed one-way slab of length L for a simply supported? Not only for simply supported, if you take cantilever or if you take for a beam one end continuous or for a beam both ends continuous, the thickness will be L upon 24. It is a standard value. Coming to the next one, what is the maximum bending moment of elastic plates in a square slab? If you take a square slab, the load distribution is uniform, that too half of the load. So you can take the formula W by 2 is the load, half of the load, L square upon 8. If you simplify, you will get the answer option C. Okay. Moving to the next question. What is the load factor for stem in the design procedure for a cantilever retaining wall with the safety? Again, this question is based on American code. My dear, option B is correct. As per Indian standard code, we are going to take 1.5 is the load factor in the design, but as per American code, it is 1.6. Coming to the next question, which one of the following comprises 2 or more footings connected by a beam called strap? My dear, it is a strap footing, but in the options they have not given a strap footing. Strap footing is also called cantilever footing because the beam will act like a support and the column will act like a beam. So it is also considered like a cantilever footing. Option D is correct. Coming to the next question, a one-way slab has a effective span 3.6 meter and is 150 mm thick. The live load expected on it is 3 kilonewton per meter square. What are the design shear and loads for checking the serviceability respectively? My dear, let us calculate the first total load. Total load is equals to dead load plus live load. Here dead load is nothing but self-weight. Self-weight you can calculate gamma into D, where gamma for RCC is 25 into D, thickness given 150 mm, let us write in meters. You will get 3.75 kilonewton per meter square. And you want the total load equals to dead load plus live load. They have given here, live load is 3 kilonewton per meter square, so 6.75 kilonewton per 6.75 kilonewton per meter length you can take it. So if you check the options here you can eliminate remaining options. Option A is correct. If you want a design shear, you can take it. Design shear VU is equals to 1.5 times W L by 2. If you simplify, you will get 18.225. Okay. Moving to the next question. Consider the following statements regarding the strength of flange sections in flexure where the moment of a resistance capacity of the flange sections depends upon the depth of neutral axis XU. Here given three statements, my dear. First statement is XU less than or equals to DF. Compressive force in the flange, compressive force is in the flange only, no doubt. Whenever neutral axis lies within the flange, then you can treat the section like a rectangle, and in the flange only compression is developed. So statement 1 is correct. Coming to the second statement, if 3/7 XU greater than DF, compressive stress in the flange is uniform. This is the first condition, my dear. DF upon XU less than or equal to 0.43, or you can write DF less than 3/7 XU. According to the meaning of this condition is within the flange stress is uniform. Within the flange stress is uniform, which is equals to 0.446 FCK. Anyway, option statement 2 also correct. Coming to the statement 3, same condition given here, but here given compressive stress in the flange is a non-uniform. Here df is less than 3 by 7 xu. Again same, my dear. So stress is uniform, but here given non-uniform. So 3 wrong, 1, 2 correct, 1, 2 correct, option C. Coming to the next question, my dear. Which one of the following is the equation for width of the step? In a staircase, consider R being the rise and T being the tread, D by 2 being the depth and B is the width. My dear, this is the rise, this is the tread, rise, tread. They are asking width, B is equals to root over R square plus T square. Option B is correct. Moving to the next question. Again the question is given based on ACI quote, my dear. Which one of the following statement is correct under safety provisions of the ACI code? Okay, here given design strength is greater than the required strength. My dear, design strength we can take like this. It is FCK upon partial safety factor for a material. So design strength should be always less than the actual strength. Here given greater, so A wrong. Here given greater, wrong. C given design strength is less than the required strength. No doubt it is correct up to this. Coming to the continuation, design moment is greater than the required moment. No doubt. MU is the design moment. Some load factor into the working moment. This is the design moment. No doubt. Option C is correct. Okay. Moving to the next question. Which one of the following is not an effect of a wind on a structure? A, the effect of wind on a structure depends upon the density and velocity of the air. Absolutely A correct. Coming to the B, it depends upon the angle of incidence of the wind. No doubt it is also correct. Coming to the C, it depends upon the shape and the stiffness of the structure. No doubt it is correct. But the question is not. So option D. This one is not the option. This is option. These are the correct statements. This is not the correct one. So option D is correct. Okay. I hope you will understand. Thank you, dear students. I wish you all the best.
Right, students. So now we will discuss the transportation engineering and geology. Right. So from that transportation engineering, the first question came is what are the two main categories of embankment slopes? So direct answer, that is hazardous and non-hazardous slopes, embankment slopes. Right. Coming to the second question, match the following. So they have given median width here and they have given the key features like which median width is used for which one. So like here we can see this is 4 feet wider, that means very small. So if you see the option, this related to option number 3 because it's provide pedestrian refuge only. So P is coming with 3. Then coming to the next one, that is 16 feet wider, more than the first one. Where it will use? We'll use it for provides pedestrian refuge and room for a left way turn. So R is coming with 2, right? And then slightly greater than that, that is 20 feet wider, that we'll use it for this one. Provide pedestrian refuge room for dual left turn bay. So S is coming, I can say S is related to 1 and at the end the last one Q will be related to 4. So if you see answer 3, 2, 1, 4, that is Q is equals to 4. So this one is matching. Answer C is the correct answer. Right. Next question. See here, if VD is the design speed in mph, that is nothing but miles per hour, and you know that our IRC code deals with kilometer per hour, meter per second, but here everything is given in miles per hour, feet per second. So here the question is slightly tough, or you can say it is not related, because as we Indian follow IRC code, but these are not related. So if you convert mph to kph, feet per second square to meter per second square, and then you calculate, you will get option A is the correct answer. Coming to the next one, this one, if VD is design speed, again if you see question number 5th and 6th are almost the same, that is given in miles per hour, not in kilometer per hour. So here you can relate that R minimum, this formula something E plus F. So here E minus F, option wrong. Here also E minus F, option wrong. And then if you convert mph to kilometer per hour, then you will get option D is the correct answer, right? Coming to the next one, the weighted average of the damage caused by individual axle load group with respect to the corresponding volume of the traffic of each group is known as, this is a direct definition type of question, is nothing but vehicle damage factor, right? Coming to the next one, which one of the following is a factor that is multiplied by the total traffic repetition in a lane to convert it to equivalent repetition along the maximum distress path? Again direct question, lane distribution factor, these two are direct question. This year if you see all theoretical question scheme. So this all from traffic. Next coming, this is the from tunnel engineering. Now you see what is the first given. Consider the following statement regarding tunnel. In hills with soft rock, a tunnel is cheaper than cutting. That is a statement, correct statement, true. Next, the maintenance cost of a tunnel is considerably high than that of bridge. Yes, bridge there is less maintenance, whereas in tunnel we have more maintenance. So this statement also turn out to be true. The third one, the construction of tunnel is costly as it requires special construction. True. So if you see all the three statements are correct. So they ask which of the above statements are correct. 1, 2 and 3, all three are correct. So option D is the correct answer. Next, match the following. Now here you see what is given, size of the tunnel given and purpose of the tunnel. Now you know very well, if you see this one, horseshoe tunnel is used for railway and roadways. So R is related to 2, no need to see others. If you see the option, there is only one option, R is related to 2, that is option B, correct answer, right? Next, consider the following statement regarding full face method for tunneling in hard rock. Means a big full face, complete, through a rock, complete tunneling at a time when we do. So an entire section of the tunnel is tackled at one time. That is very correct statement. Mucking tracks can be laid on the tunnel floor and extended as the work progresses. That is also true. It is suitable for unstable rock. Now here you see, when we do full face method, that means a big section is cutting through the rock. So if it is an unstable rock, there is a stability problem, and if you cut it, then obviously this will lead to a stability failure. So this is not correct. So correct answer is 1 and 2 only. So option A is correct, right? Next question, which of the following method is achieved by drilling a drift through a tunnel from portal to portal, means end to end? When we try to drill a hole from a rock or to make a tunnel from end to end, what happened? Dust particle will come into picture and we need to take it out. So the best method will be blowout method, right? Now next, see, accurate transfer of the surface alignment down a vertical shaft. This term vertical shaft is used for tunnels. Used to plumb wear can be achieved by rise and fall method. You know this is a height of instrument method, right? Yes or no? Or you can say just leveling. sorry, not height of, this is a leveling method. This one, collimination method, is your height of the instrument method. This is leveling, this is height of instrument, and this one, bow ditch method, this one also used for traversing. So now we are left with only one option, that is D. So use elimination method to get the correct answer, that is Wayback Triangle method, right. So this is all from highway and traffic and your tunnel engineering. We have one question from geology. Let us see it. Which one of the following situation is not at all suitable for tunneling? So if you read all this, you will see this B, if the beds are vertically dipping and the axis of the tunnel is perpendicular to the strike, then what happens if you make a tunnel, you will strike through the surface and it will lead to you instability. So this option is not suitable, is option B is the correct answer. So that is all from highway traffic and geology, and I hope you done it good. Okay, thank you.